أهلا بيكم في بودكاست كربون. معاكم أحمد رجب. Okay, welcome again in the first episode for this year, 2025. And we selected a very hot topic to start the year with. So it is very interesting topic for all the chemical engineers around all the industries. So I'm really happy today that we have the very top-notch experts. And our episode today will be on the process simulation. And as you all know, it is a very critical, very crucial topic. It is very important for everybody in the chemical industry. So that's why today, to cover this topic, the process simulation, we selected again one of the top notches experts that we have. We have today Fauzi and Hassan. Fauzi has over 20 years of experience in the process simulation. Hassan also has over 15 years in the process simulation as well. And actually, I've been very lucky to be working closely with both of them for a good certain time. And I really have learned a lot from them through my journey with them. And I took that chance to transfer that also with our audience in Carbon Podcast. So let's just start with our experts. So first, Fauzi, you can start and introduce yourself to our audience here. You are very well known, but we need you to introduce here.
Yes, thank you, Ahmed. It's a pleasure to be here in your Carbon podcast, right, along with Hassan. Yes, I started my career mainly in engineering. I spent, I think, about 16, 17 years in engineering upstream, then with midstream with Wally Parts and some refineries. Now I work with the software company, basically serving, providing consultations to customer around mainly Southeast Asia. Yes, good to be here.
Yeah, thank you for joining us, Fauzi. It is our honor. Yeah, thank you for joining us. Yeah, Hassan, go ahead.
Thank you, Ahmed, and it's my pleasure to be here and to join you and Fauzi, of course. So welcome, everyone. My name is Hassan Benhawi. I have over 15 years of experience in process engineering, different rules, different industries, and I'm happy to be here with you today. Hopefully, it will be an open discussion. You can ask whatever you would like to ask, and we will try to answer all your questions, inshallah. Thank you.
Yeah, most welcome, Hassan. Yeah, we are so happy to have you here. Such an old friend. Yeah.
Yes,
and
definitely.
okay, let's start. Yeah, let's start our episode today. And we have, as I mentioned, very important topic for anyone that working in the process industry or the process any chemical industry, which is refinery, petrochemical gas, or anything. And as we are talking about the process industry or the process simulation in our industry, so we need first to start with the origin of the process simulation. And about talking about that, we need to go like a little bit back before the very advanced software on the process software simulation, and talking about more like the process simulation and the numerical modeling and so on, about the concept of that one. So let's start with this one. Let's start with Fauzi. Yeah, Fauzi, go ahead.
Yeah, I think for me, process simulations is basically a tools for calculations, right? But it's this, with these tools we can perform faster, much more complex calculations. So what are the calculations typically? We as process engineers, right? We handle different fluids which has a different properties. So we do need some kind of a model or approach to estimate this the properties of the different fluids, right? So it can be to calculate heat transfer requirement, pressure drops, etc. Right. So these are the probably the thermodynamics models, right? And I guess the other thing is also we handle all different types of unit operations in the plant, right? From the simple like pumps, compressors, which is only increasing or changing the pressure, but there's also a more complex like we can step into like separations, distillations, all the different types of separations, then going into reactor, right? So there are changes of the fluid going into the unit operations and coming out, and this also with simulations we can help to estimate or predict what could be the performance of this unit
True.
operations. I think the third element probably is the so all this is maybe in the past is done using hand calculations. Of course, there's certain calculations to be iterative, etc. Then that's where numerical model might numerical method might actually help, right? So I think maybe probably this is are the core elements of process simulations. Yeah. What do you think, Hassan?
Yeah, Hassan, I think yeah, you have a lot to add. Yeah.
Okay, so I have a couple of points to add to Fauzi. So everything started with mathematical modeling. So it's like defining your process in terms of equations, mathematical equations.
Mm.
So this is how we started the process simulation. I think it started at the 16s or 17s, something like that. And after that, the main development came, I think, with the introduction of HISES when they introduced this graphical user interface where you can do everything easily. And from there, it started to be simulation. You can put your equipment, and the mathematical model will be in the background. You will not see this, but it's working in the background. So this is the start point of simulation and modeling. And what makes it very important now is availability of computers and the hardware required to run this kind of software. It wasn't there before, so we are lucky that we have such tools right now, and we can utilize them and use them as Fauzi mentioned. And I think it's HISIS or simulation. It will not make you as a good engineer. You should be a good engineer, and based on that, you will be able to utilize simulation tools in much better way, and you can understand them. And based on that, they can be a very useful tool for you that can make you help others and help yourself also. So this is what I need to add here. Thank you.
Yeah. I think it's very clear. Yeah, from my point of view, I think the process simulation it started very long time back, maybe back in the old history. It started when the
Mm.
old scientists, like the mathematician or a physician, when they try to find, as Hassan mentioned, like or and Fauzi mentioned about they need to find an equation that it can describe a system, right? So if we have any system like in the astronomy or any like the simple physics or even the chemistry later on, they wanted some equations that they can write on the books to describe the system. And from here it came the idea of the simulation, that we can simulate anything that we have, and then it transferred to the industry, not only in the chemical industry, but in many other industries, mechanical, electrical industries. Even they have a lot of simulation work using the mathematical equation to describe the system. So Yeah, it's very interesting that we have the systems that we need to describe. And from that point, this will take us for the our next point in our episode today, which is the application of the process simulation. So now I have the equations, now I have all the mathematics which is describing the thermodynamics models or any other models that I have. And actually, I found that a very big challenge. And we need to highlight that very precisely in our episode today because I found many, many engineers, they are talking about the simulation. But when it came to the real life application, they got stuck. They really don't know how to apply. They thought that, oh, I need to simulate the full plant or the full unit, which this is not the case. There is other many, many application of the process simulation. So I think, Fauzi, you can give us a clear vision about that one. Yeah. So please go ahead.
All right. So maybe if we break it down, typically we group it into two main categories.
Mm,
The first one is related to operations, right? So I'll talk about the design first, right? So the design is basically right. So this design, it can be for a greenfield, it can be for a brownfield, right? But basically, when you're designing a plant, typically you want uh, to have the heat and material balance, right? Do you want to determine the capacity of each of equipment, the load of each of equipment? So this is the process simulation helps in terms of predicting, generating,
mm,
let's say, for example, this much of feed for this type of feed. What are how is the different technology, the process unit operations will produce the difference of let's say product streams with different qualities, right? So this is, I think, one which then the informations of that information is used to actually for developing sizing the equipment, right? Specifying the equipment, right? That's the
mm,
for design. There's a lot also. I mean, that's the general for hidden material balance, but we also have different small different tools, right? We have tools for um doing safety studies specifically
right.
for example, relief valve, blowdown calculations, and if we see also process simulations in the hidden material balance is steady state, but during design also we will perform some dynamic simulations, right, to check certain for example, compressors is very typical that we perform search analysis, which is a dynamics study, right? It is part of the
Yeah.
design. We want to size the recycle line, the hot gas bypass line, right? So there are different use of process simulation. Even in dynamic simulations, you can take that as a seed model for your operator training simulations, right? So this is actually helps in terms of validating your startup procedure, your shutdown procedure, preparing your team to actually go into the commissioning and the startup of the plant. Yeah, maybe I'll elaborate the design part just now. Then
Mm,
maybe the operating part, uh, maybe Hassan can take it forward.
yeah. So Hassan,
Okay.
yeah, I think we need to,
Yeah.
yeah, to focus more about
Okay.
the application. Yeah, tell us more.
Yes. So yeah. So let me talk about this from my previous experience. I will tell you because I used to work in an operation before, and I understand what we
Mm,
can utilize such tools for. So usually, the first thing that I can think about is equipment monitoring, where you can get all the available data related to one kind of equipment, and then you can calculate such KPIs required for this equipment, like fouling for heat exchangers or efficiency of compressors or pumps. So you can do this for your equipment. Another use case is what we call the management of a change. And part of this is to understand the impact of this change on our process, or if we need to design it from the beginning. One thing that we have also is to monitor the CO2 emissions and to understand the impact of this change on CO2 emissions. There are a lot of cases that we have utilized simulation for. And as I mentioned, it's your first tool as a chemical engineer. You need to have such a tool in your hands to play with. It's an essential thing. So you need to have the good understanding and then to apply this understanding utilizing some simulation to do the monitoring, as I mentioned, the optimization. This is one of the things that usually you may need to do, and you will not see the full picture until you do it through a mathematical model or through a simulation. And again, I think we will cover some of these also under the digital twin. So I will leave some other things under digital twin as we can utilize this also for any operation. Finally, something that I'm thinking about is training of operators, the OTS. Where you can train your operators, you can train your new engineers. So it can be useful in many things. And I think with the understanding of digital twins, we will have more clear idea what simulation can do for us, other than all the applications that Fauzi and I talked about.
Yeah. So I believe just to recap a little bit, it is the process simulation. It can start from the very simple calculator, right? We can use it as a very simple calculator. If I have I need to calculate some mixture viscosity or a viscosity for a mixture of components, or boiling point, or partial vapor pressure, or whatever. So I can use the simulation. As we mentioned, it describes the system, right? So I can use the simple equation or any software to do that. And then I can capitalize on that, starting from the plant monitoring or the process optimization, even up to the plant design, right? Some of the simulation softwares can be used for the full plant design, and even, as Fauzi mentioned, some process safety studies, relief studies, and calculating the relief loads and so on. But I just want to focus more here about the because this is very important for the operating plans, and I think we are targeting more the operating plans about the process optimization. We will talk about the digital twin, as Hassan mentioned, later on, and the beauty of the digital twin. But right now, some or some misunderstanding or confusion within many process engineers, with many operating plans, about the optimization. So let's talk more about the optimization itself and how can we utilize the simulation to do the optimization for any operating plant.
Yes. So do you like to go ahead, Fauzi, or shall I go?
Okay, let me try. Right. So I think optimizations for me is like finding the finding the optimum, right? But how I define it is, okay. It's as simple as finding minimum or maximum, right? But in optimizations, there one factor is what are the parameters we can change, right? So and this could be let's say in distillation column, it could be reflux ratio, it could be the reboiler temperature. So we need to understand what are the handles to operating handles, right? Operating parameters we can change, right? But this parameters also has constraint, right? There's no, you cannot say I can run from 0 to 10. It really depends on the constraint of the system or equipment, which is also described, right? So that's how I see it. So we have handles, we have some constraint. Now we have to maximize certain objective, right? So the objective could be the objective itself is also going to be described in equations, right? For examples, uh, maximize or minimizing energy use, right? So we can calculate the energy consumptions for a system, let's say for the boiler, for the condensers, etc. And we try to add this and find, based on the possible operating range, where is the best operating range which will make minimum the most the lowest energy consumptions. I think that's how I describe the optimizations, right? It can be for minimizing, it can be also for, let's say, maximizing certain stream product stream, right? So you might have a high value product streams, then you want to maximize the productions for that product stream, right? So then you try to maximize. So there are different objective functions. We can describe the objective functions in an equations, considering what are the parameters we can change and what are the limitations.
Yes, thank you,
Hassan,
Fauzi. Also,
Hassan,
I
yeah.
can yes, I can add some points here. Um, the scope of the optimization, it's very important, because you can start looking at one equipment, you can start looking at one unit, or maybe the full plant. So the scope is important, what exactly you need to do and how to do it. So this is the first step, is the scope of your work. One thing to add to what Fauzi mentioned, sometimes it's not only about maximizing the capacity or one stream. Sometimes, and I have seen this, you need to extend the lifetime of your plant or your operation a little bit. Sometimes you have something like as a plant shutdown at a specific time, and you need your plant to survive till this point. So we have seen this also. So there are different, let's say, targets, and based on your target, you can tune your simulation to achieve the best results that you need for your plant. So this is in addition to what Fauzi mentioned related to optimization.
Yeah, yeah, yeah. Actually, why I mentioned that, because as I told you that I found that maybe it is very short journey for me, like the last 17 years. But what I found that many engineers, they got themselves confused in the terminology optimization. So once they said the word optimization, the first thing that pop up in their mind, it's the energy reduction, right? But I think the optimization, it should include many things, as Fauzi mentioned, and as you, Hassan, mentioned. First, we need to define the scope of the optimization. It can be energy, it can be yield, uh,
Yeah.
it
CO2
can be
emission.
it can be, yeah, it can be the emissions, and it can be even the manpower, or the manpower, or the man hours. Okay, it can be the business itself. In some certain cases, the optimization can be related to the business, but it need to be done by the process engineer to reflect that. Um, Scheduling, production planning, and so on. It has many things under the word optimization, and process simulation. It can be applied in all of those, providing a very robust results, very reasonable results as well. It doable. It can be done, and all the plants can achieve that. So as I just don't want to run out of time, because I know that we have a very limited time. So let's move to the next topic, which is now it is very everybody's talking about the AI, right? And the fancy AI now. It's the war between DeepSeek and the open AI and the rest of things. And by the way,
ChatGPT.
the funny thing,
Yeah.
ChatGPT, and the funny thing that I don't know if you hear that France, they launched their own AI model. It named Lucy, and they start to ask some question like, does the cow like the cows laid, or it got eggs? It said that the cows get eggs. So it was like a big fail. Yeah. Yeah. So let's talk about the new trends and the process simulation. And as Hassan mentioned, that he already shed some light on that one about the digital twin. And later on, we can talk about some other new trends, which is the combination between the process simulation and the data analysis and AI and so on. But really, I'm really want to share with our audience our experience in the digital twin and the application of the digital twin. So, Fauzi, you can start. Yeah.
Okay. Yeah, I think I'll continue from what Hassan mentions, right? I think Hassan mentioned about the scope, right? So is Hassan also mentioned elaborate about the monitoring. So it's very similar. So digital twin is basically we are taking the model and like you might have models, right? But to have operation model, right, you have to incorporate more details so that it can do the predictions. Like for example, a little bit of kinetics for the reactors, compressor curves, etc. Right. So you add depending on what you want to predict, you add more details. And the other things you need to do also is you have to make sure that this model is reasonably accurate, right? So you do what we typically say as calibration. You take some plant data set, right, and try to adjust parameters in the process simulations to match with the reality in the plant, right? The measurements in the plant, right? So once we confident with this model, then it's actually once we use it as an
Up.
offline, then we can also
Mm.
use it online. Means that it connects with the data historian. The data directly from historian is mapped to process simulations. We can do some data in terms of data treatings, etc., data conditionings before we pass it to the process simulations, right? So this again similar like you mentioned in terms of the use in operations is it can be monitoring, it can be uh, optimizations. But now we have these tools which can run
Yeah.
automatically, right? Automatically, rather than engineers. For example, engineers might be actually doing a lot of routine calculations. It could be daily, it could be weekly, but this is now all can be automated, right? This time to a more higher value task, right? Because they don't have to perform all these manual
Mm.
calculations, transferring data from one place to the other place and perform the calculations. I think
Yeah.
this is maybe a little bit overview of that.
I think we have a very good question here. I think it's already explained. What do you mean by digital twin? Yeah, I think we already explained the concept of digital twin. Yeah. So, Hassan, we can.
Yeah, we
You
can
have
review
any? I
this
think
very
right.
quickly.
Yeah.
Okay. Yeah, sure. So now, digital twin is, I will say that there could be many meanings for that. So, like a specific group of people may give this like a different meaning. Okay, but
Yeah.
I will speak about ourselves, both Fauzi and I. The meaning of digital twin for us is a model that is running online. This means, as Fauzi mentioned, the model is taking the data from the historian. This is real-time data. He do some cleaning. The model will do this, and then process these inputs for the model. The model will run, and all the results will be available for you, real-time results. And from there you can take these results back to the historian, or you can use them as whatever you want. You have all the options to work with that. But the point here, as Fauzi mentioned, you need a high fidelity model, in other
Yeah.
words, an accurate model which represents your blend exactly. And for this, we also use some AI capabilities to do this. Maybe this is one of the use cases of AI. But again, you have the model; it's connected to your historian. This means that you have all the calculations available for you, all the monitoring, all the everything, and it can be also. Let's say able to do the optimization and give you the optimized parameters. And to add to these two use cases, one interesting use case is data reconciliation. So in data reconciliation, the model can check all the measurements coming from the plant, and he can reduce the error between all of them. So this is another application of digital twins. And again, you can send these data back to the historian, or you can keep them for your work as you need. It will be available for you.
Yeah, so I hope that the definition of digital twin, it's very clear now. And we have another good question, Fauzi, if you can help us here to highlight this one. I think the question here mainly that should we build on the steady state model or dynamic model? This is very good question. Yeah, or steady
Okay.
state mood or dynamic mood. Yeah.
Yes. All right. Good. Very good questions. I think I would say most of the digital twin model is built in steady state model, right? So you feed the data real time, you run the calculations in steady state. But I also have seen a model to actually uh, use a dynamic simulation, more of like predicting, forecasting the future, right? So you feed the data, the current data, and you use dynamic to actually trying to forecast the behavior of the system, right? So yeah, my short answer, I would say 90-95% of the model for digital twin is based on steady state. It's just that it some people a little bit, maybe I wouldn't say confused, but because of the model continuously running and updating, some people might think that that is dynamic. No, the
Dynamic. Yeah.
model,
Yeah.
that one is still steady state, but it's just run more frequently, right? You generate the result more
That's right.
frequently. Yes, but I do have seen one or two cases where actually a dynamic model is fed with real time data also to forecast. Yes.
Yeah, I think, yeah, I fully agree with you. Maybe the confusion it came because the model is connected to the real data of the plant, so it came to the mind that, oh, this is dynamic because it's refreshing the results every like whatever the frequency. So maybe it came like dynamic. I have another question, and I would like to give this question to Hassan. I think it is the same concept. Like, how often do you run the digital twin? Michael
Um,
actually he shared a lot of good questions here. Yeah.
yes, I can
Yeah,
see.
yeah.
So it
Hi,
depends.
Michael.
Yes, hi, Michael. So actually, it depends on the use case that you are building the digital twin for. So, for example, if you are building a digital twin for fouling, you may run this like every week, let's say. If you need to do this for something that is more quick, maybe you can run it every 10 minutes, every 15 minutes. It depends on your use case. It's not something specific.
Yeah. Yeah, actually, as you mentioned again, and I think because I have faced this very recently, some engineers they thought that digital twin it should be online 24 hours every second. It should give some output, and I'll take the opportunity here just to mention that, as you mentioned, Hassan. Again, it depends on the data availability, right? So maybe we need some samples from the laboratory, which it can be every day, every week, every month. It depends, right? So I need to run my model or my digital twin every once in a month or once in a week. It depends. And the other thing that maybe we need to also highlight about the digital twin, about the types of digital twin. It can be open loop or it can be closed loop digital twin, right?
Mm,
So
yeah.
also we need to highlight this difference here. So Fauzi, if you can give us like a small brief about the differences between open loop and closed loop digital twins.
All right. Okay. So I think open loop means that basically the digital twin is showing the results, right? So showing the results, but the action itself
Fauzi,
so-called
we are losing you a
advisory.
little
So
bit.
the result we're showing, it could be uh, oh, sorry. Yeah. So
Yeah,
yeah, I was saying that open
go
loop
ahead.
could be, we can sometimes we call it also advisory. So basically, we are showing the
Yeah.
calculations result. It could be calculations from the monitoring. It could be calculations from the optimizations. Then the operator actually sees this result, make the decisions, then implement it. Right. So implement it by changing the control systems, the targets, etc. Right. So there is actions need to be taken by a human or operator to apply or implement the recommendations. That's open loop, right? So if it's closed loop, that means we actually remove this kind of human taking actions. The actions or the the calculation performed by the digital twin basically resulting into let's say a target set points, right, which then send directly to control systems. Typically we send it this to a layer of advanced process control, right, then which also will act on
Yeah.
the the DCS control, right? So that's
Mm.
the difference between the open and the closed loop.
Yeah, yeah. And another thing that also some confusion that I heard recently about the closed loop, as you mentioned, because it should be connected with the APC or the advanced process control. And some people they start to imagine this will be a fully autonomous plant, right? So it's running by itself. And actually, there is one real case, one plant in Japan. It's already like a fully autonomous plant, refinery, uh, but it's still like not. This is like not the common thing. And again, and the closed loop as it's connected to the ABC, so we still need to define the limits, like the upper and
Mm.
lower limits, right? So to avoid that, we are going beyond our limits,
Yeah.
and the
Yeah.
plant will start to be in a big hustle. Yeah. I think we have another good question about digital twin before we moving out from the digital twin. I think we have two questions, and both maybe they have the same meaning or the same thing. Can we trust these models in terms of accuracy? So Hassan, I'll leave this question for you.
Definitely, we will not put this model until it's already accurate. As I mentioned, usually it's what we call high fidelity model. So it will be accurate. It should be tested before being put in action. And again, as I mentioned, this is one of them of the use cases of AI where we will put an AI layer that will try to do the assumptions instead of us, and this will make the model matches the plant
Yeah.
output. So yes,
Yeah.
we can trust that.
Yep. Because you need
And
to validate.
yes, sorry, Ahmed, for the interruption, but as you mentioned, also there will be also a cleaning step for the
Exactly.
data input for the model, and there will be also some limitations that if something happened, the model needs to stop at this point.
Yeah, sure. It is the same sequence that we are building a simulation model that we need to clean the data first, right? We need to, if we are building on the plain data, and it needs some validation. So to make sure that the model is mimic the plant on a very
Exactly.
accurate
And
way.
your design, your plan design is based on a simulation file, so you
Exactly.
have to plug
Yeah,
this.
exactly. That's right. That's right. And I think we have the last question about the how often do you run the digital tool? I think we already answered this one. Yeah. So
Yeah.
and what kind of tools to calibrate the digital twin? I think Hassan also covered this one.
Mm.
Uh, like
Plan
yeah,
that.
we can use
Yeah.
the blend data, and we do the data reconciliation and make sure that we clean the data before the input. Yeah. So I'll move to the another trend in the process simulation, and maybe this can take us to the next very also interesting topic, which is as you know that as we mentioned that the AI now is very trending and that it is booming everywhere. So from your point of view, and we can start with Fauzi again. What is the application of the AI within the process simulation, and how can we uh, incorporate the AI within the process simulation?
Okay, I think the way I think there are three applications of AI currently, right? Of course, the first one is it helps with building model with all this data, right? So and some unit operations or some properties still cannot be described by engineering equations, right, or by thermodynamics equations. So, but it is measured in the plan, right? We have the data, so we can actually build the model based on this data. I think this is one applications, basically building model from the data to explain
Yeah,
certain behavior or to predict certain behavior, which we haven't have the engineering model yet, right? So I think this the second applications, right? So we have the plant data, right? I think digital twin, one of the prerequisite is actually to calibrate or to match this plant data, right? In the past, we calibrate with typically one data set, right? So it could be like one data set resulting into uh, a set of calibration factors, right? But again, typically because we calibrate in one data set, so that means if the operating conditions change significantly from that data set, then the calibration factor is not valid anymore, right? So with the AI, we can actually collect more data sets and
mm,
build the model to actually adjust automatically this calibration factor, right? Or create the different calibration factor set, right? Which look at the operating condition or look at the relevant parameters and adjust automatically this. I think that's the second, and I think this is really useful, right? It allows our model to be more accurate in a wider range, operating range, right? The third one is what we call is we typically now trying to perform calculations in a bigger flow sheets, trying to optimize a bigger flow sheets, right? So the challenge is convergence speeds, etc., becoming a challenge, right? So we can actually we can simplify this model. What we call is we pre-run the model, right? We pre-run the model and collect the data. Using the data, we build a data model, right? So this is like what we call reduced order model. We're simplifying the first principle model, right? So
yeah,
this allows to model to run faster. So that means we can run more cases, we can run bigger flow sheet, right? For the optimizations. I think these are in terms of the concept, the three uh, concept of use of AI.
mm. Yeah. Hassan, if you have anything in addition?
I think with the current revolution of AI, we will see a lot of applications. Fauzi just mentioned most of them, and I believe that there are a lot of people who approach me they are
Yeah,
doing a lot of good thing, and it's still an academic things, but it's very interesting. Like this integration between ChatGPT and ICES, how to build a model using voice command or using picture. It's very interesting. So I believe that we will see a lot of things. It's yet to come, and this will make the building of the model will be much easier and more, more time, save more time for us
yeah,
using
true,
this
true.
kind of AI. Yeah.
Yeah, sure. Yeah, I think the most applicable part right now, as Fauzi mentioned, and I think it is very interesting for me at least, which is the the using of the machine learning and combined with the first principles, which is the process simulation or the thermodynamics equation. So it is some kind of, we are adding another layer of the accuracy of the calculation by using the machine learning and generating the correlations between all the variables. Yeah. So
For me, there
yeah.
is one application that is very interesting and it's happening now. It is a combination of the reduced order models with the planning models for refineries. As you know, in refineries, they need some kind of models for planning. And nowadays, we do reduced order models, so it can represent the real plant, but it can
Mm,
calculate very faster, and this can be combined with the planning models, and it will be um, it give a lot of more of accuracy and time saving for these kind of applications.
yeah, agree. I believe that we have many questions, so maybe we can like leave the question till the end of the episode, because I need to move to the last part of the episode today, which is uh,
Challenges.
the challenges. Yeah, we have been talking about that. This is the very thing. Maybe it is beyond the technical discussion that we have today, but it is really one of the important topics that we need to talk about and highlight in our industries. The challenge and resistance for many corporates to shift to be a simulation oriented or a simulation culture oriented. So we need some case studies without mentioning the names. Just we need to elaborate that those challenges and how can we overcome those challenges. How can we make the people more trust in the process simulation and its application? I think
Uh,
Fauzi, you can start again. Yeah, it
Okay.
is your favorite topic. Yeah.
Okay. I think it is my favorite topic. I guess simulations is another tools, another technology, right? So we always talk about how we can adopt this any technology, right? So I guess
Yeah.
one is definitely getting the buy-in, right? It's not just the buy-in of the working level, the buy-in of the executive, also the management, right? With that buy-in, I guess it is easier to do initiative, right? So the other thing also I think is so maybe a little bit scattered, right? So also, one is the other part is the capability building, right? It is a new tools. There are a learning curve. It could be steep, it could be
Yeah.
whatever, right? So depending on what we want to apply or learn, right? So there is a learning curve definitely. So there is a investment in terms of time and effort to learn the technology also, right? So then we in different companies I seen, right, the challenges is the team. It could be
Yeah.
first they're not equipped. Second is also that they are busy firefighting with the operation issues, right? So they don't really have time to use these tools to build model to do analysis using this tool. So it needs either it could be organizational change, right? Allocating a specialist, etc., or it could be adding a little bit of uh, not sure the adding manpower is the right word, right? So, but
Yeah.
I think kind of like um, helping them to allow them to actually invest more time to build the tools or to use the tools, right? Because I know
Yep.
because of the learning can streamline your workflow, your calculations. Yeah, so that's I guess having that buy-in early helps into in smoothing that journey.
Yeah, I believe even if the team has a good capability, you mentioned that maybe the team that himself doesn't have the competency, but
Hmm.
sometimes the team will have a very high competent, and they
Hmm.
are very skilled even in the simulation itself. But I
Yep.
think it's all the trust, right? It's all about the trusting to shift to this culture. And what is the benefit, right?
Yeah.
Most of us as engineers, this is the first thing. What will be the benefit that I will take from shifting to the simulation? So, Hassan, I also need to hear from your side about the
Well,
challenges.
well, okay. So to be honest, I was lucky that most of the people that I met, they are aware of simulation. Every one of them, they know exactly that simulation is a very uh, essential
Mm,
tool for them. No one will live without a simulation, even because even if you have your own calculation or your own stuff, you still need, as you mentioned, these physical probabilities to do your simulation.
yeah,
Like what is the density, what
yeah,
is the so you still need
right.
this. So for me, I guess it's not something like a challenge, but the main challenges that I face is the understanding of the capabilities of the tool. This is what exactly,
Mm,
because some people think that they will do like this and the tool will solve their issues. It's not like this.
mm,
You need to be a good user. You need to have the good understanding of all the different aspects, and then the simulation is just a tool that will help you. So this is my challenge actually.
yeah, yeah. I believe that from some case studies that I have seen that, as I mentioned, it maybe the challenge it came from the business case itself and to justify because any simulation culture transformation or any transformation it needs some investment and to justify this investment there should be some payback, right? Some in some cases the payback is not like the it cannot be translated in a dollar sign. It will be, or how can we say that it can be enhancing or improving the ecosystem in the workplace,
Yes.
saving some man hours, and at the end this will be translated in dollar sign. But at the first place we cannot like calculate that, we cannot like show a very robust business case about the simulation transformation or to transform to full simulation plans, or the cultural transformation as well. So it need to have like some more how to say that full understanding from the management and the company or the corporates about the importance and how this will enhance the thing. So I think that was the last point in our episode. I'm really thank you. But before we go, we have many questions and in the comment sections. So I will try to get them one by one, and then we can start uh, answering those questions because this is very important for our audience. I will take the first question here. It mentioned that can you explain the necessary parameters they need to create a model, such as modeling in Espionage or whatever, before go to the simulation part? So I think he's asking about what should be the this is the first step, right? The necessary parameters. Yeah.
Yeah, so it depends on what you are trying to do. So
Yeah.
each process will have different
Yeah.
parameters, but I think you will build your component list, then you will identify the fluid package that you would use, then all the available inputs for your process, and that's it. You have a simulation.
Yeah, yeah, yeah. I think it's very straightforward the process, yeah, and we know the. There is another question from Ahmad, and this take us back to the digital twin, but maybe this time because Ahmad he is working as a mechanical engineer. Have you encountered a digital twin model that integrated reliability programs and equipment maintenance like CMMS? Which the actual real-time process simulation? If so, how accurate was it? Yeah. So Hassan or
So
Fauzi,
I
if
would say, okay, I will say that most of our background is process engineering, so we will not be like very useful here. But I'm aware of some of we have
yeah.
some tools that is related to maintenance. We call
Mm,
it APM or asset performance management. And in these tools, they use the simulation to build some agents, and these agents was fed to these tools to be used for the prediction of the failure of the equipment before it happens. So this is one of the use cases, but personally, I don't have this kind of experience, so I may not be the right one to answer this question. So Fauzi, maybe you have some information here. Fauzi, you still there?
Fauzi, can you hear us? Oh, yeah, we are talking about
I think
this. Oh, sorry, go ahead.
yes. I think in yeah, I agree with Hassan. One thing I've seen how probably uh, process digital twin, right? The calculation result from the process, it could add into the training the data model for the failure predictions, right? Because it adds the different data parameters, right, which can be also used to train the the data model for failure prediction. I think that's the part which I think the link between the process digital twin with maybe failure detections, right?
Yeah, I believe there's many tools that is now working as a digital twin for the reliability, and I have seen that like in some corporates and some companies they are providing the services, as Hassan mentioned, and there is some other softwares which is really I cannot mention the names for sure, but maybe Ahmed we can talk on that in private. Yeah, they have a very good softwares about the mainly on the maintenance and the integrated reliability, yeah, for sure. The other thing that, as we mentioned, that the simulation it can be your own equations, right? You can build your even if it can be Excel sheet, and then you can connect it to the real data, and then you can like do the simulation and so on. Another question, which is really very important, and because we are really our podcast here, our like we really focusing on the audience, like the fresh grad, and we have a question here from as a fresh grad with a fair with flair for chemical simulation. Can you please help us with the path to take, like some advices for
Follow
our
Fauzi.
fresh grads?
Yeah, follow
Yeah,
Fauzi, of course.
Fauzi. Yeah, sure. we are do we are doing that. Yeah.
Yeah, yeah. What? Okay, let me take a step on that. Fresh graduate for a flare of chemical simulations, which path to take, right? So I think,
Mm,
let me think. So I guess I had a similar questions, but a little bit more general. So I think as a process engineer, I see the main I categorize our main part is also two. You can be a engineer for
yeah.
an engineering company, do a lot of design. So it doesn't mean that you don't deal with operations. You might have a troubleshootings, revamp studies, etc. Right. So that's one part. The second part is the you join. You join a operating company, right? uh, in operating company, then you troubleshoot, you advise the operations, etc. Each has its own um different way, I would say. They both use simulations. Probably in design you might, depending on the stage of the design also, you might use 10%, you might use 20-30%, depending on
Yeah.
where you are in the stage what study, right? Then in operations, probably you will use more, you deploy, probably you might deploy digital twin, or you might work with a vendor to deploy a digital twin. A different I would say both use process simulation, but it's in a different way, right? So it really depends on what your career aspirations, what I would say is, of course, you can always try to improve your knowledge. It could be by training from the vendor, many things, right? So I think there are many ways of learning it, books, etc. Yeah.
Yeah, yeah, that's correct. Hassan, I think Hassan, he's the inventor of the material balance of chemical engineer. I still like this one. I'm still using it in the lectures even.
Mm.
Yeah. So
Thank you,
you
Ahmed.
can add on this, Hassan. Yeah, yeah, sure.
Yeah, I will add one point here. From my previous experience, usually you will not have this luxury of choosing. You will have one opportunity, and you need to follow it.
Yeah,
So,
Yeah.
yeah,
whatever open for you, just go and you will learn there.
yeah. That's
Yeah.
correct. And I believe that for you as a maybe fresh grad, you need really to focus on the first principle, the basic principles. Thermodynamics, mass transfer, heat transfer. This is the very basic things, and you need really to focus on that one. If your work in the future will need a simulation, and if you have a very robust background, academic background, and you have the knowledge, simulation would be a very easy task. Yeah, you can just it's a turnkey. Yeah. Okay, I think yeah we have the last question here because we already 1 hour. We have yeah I think it is the same thing about the how can I improve my software knowledge? Which tools are important where or learning it? Yeah, this is very difficult question to answer because it's the it is everywhere. Yeah, we have hundreds. Yeah.
Mm.
I think if you are like as a fresh grad, maybe if we can consider this or assume that a fresh grad, I think starting with the existing softwares like MATLAB or ChemCAD or whatever, you can start using those as a. It will be a good start. Yeah. I don't know if Fauzi or Hassan, you have any,
You know what we can recommend, but we will not say it. So.
but we cannot. Yeah, yeah, we cannot. Yeah. Okay, I think as we came to the end of our episode, and again we agreed it should be 30-40 minutes, and now it's almost 1 hour. So
Yeah.
really thank you for that very interesting topic that we discussed today, and thanks for the valuable information. It has been very fruitful for me. I'm sure for the audience as well. So thanks Fauzi and thanks Hassan. Thank
Thanks,
you.
Ahmed. Thanks,
Thank
Hassan.
you, Ahmed. Thank
Great to
you.
be here.
Enjoy,
It was
It
good
enjoy
was
your
a
day.
discussion.
pleasure to be with you guys. Thank you.
Thank
Thank
you.
you. Bye bye.
All right.
Bye.
Bye.